a possible Lewis structure for barium chloride is given below. So here is the one of the Lewis structures. Okay, for this compound, why does the resonance form? Why does this resonance form, this particular one, contribute very little to the two electronic structure for this molecule? Of course, we have different choices here. Please recall, when we talk about the stability of a given resonance structure, so we need first to find out the formal charges of each atom, okay? And then the key equation for finding the formal charge is number of valence electrons subtracted by the non-bonding electrons subtracted by 1/2 of the bonding electrons, all right? Both chlorine, actually, they have the same number of electrons, all right? So exactly the same, we just need to calculate for one of those. So then the formal charge for either of these two chlorine should be number of valence electrons, 7, because that's a 7A, group 7A element, okay? Subtracted by non-bonding electrons, that's 4, subtracted by 1/2 of the bonding electrons. You see each line represents 2 electrons, all right? That's total of 4. And then this gives us +1 for each of the chlorine, the formal charge, all right? So next, let's work on barium. The formal charge equals the number of valence electrons. That's a group 2A element, all right? So that should be 2 subtracted by, there's no lone pair surrounding barium, so therefore nothing there, but it does have 8 electrons surrounding it, bonding electrons. So therefore 8, and then that actually give us -2. So this is -2. Okay, now we need to find out which one, barium or chlorine, is more electronegative. If you recall, the arrow diagram, electronegativity increases across a period. Chlorine is right here at the very kind of the right-hand side, and barium is in the far left-hand side. So therefore, actually, the electronegativity, just using the arrow diagram and the periodic table, you know chlorine is much, much more electronegative than barium. And if you want to take a closer look, let's find out actually the value of electronegativity. Okay, for chlorine right here, let's take a look. That's 3.0. Probably it's kind of hard for you to see it, but that's 3.0. Okay, and then barium, on the other hand, very low, just 1.5. Okay, so chlorine is much more electron negative than barium. Then what problem do we have here then? You see, so based on the formal charge rules, the more, the negative formal charge should reside on more electronegative ones, the atoms or elements. Since chlorine is much more electronegative than barium, this structure is very, very unlikely because it does the opposite. So that's why this resonance form, it contributes very, very little to the true electronic structure because this is very, very unstable. So there should be other resonance forms other than this one, they are more stable. Therefore, okay, why does this resonance form contribute very little to the true electronic structure for this molecule? Okay, so we can go through all of the answers, the choices, but it is E describes the best for the reason. Why? The formal charge of the barium atom is -2, and the formal charge of each chlorine atom is +1. This places a negative charge on a metal, or in other words, much less electronegative element, and a positive charge on a highly negative nonmetal atom. It's not favorable ones at all. So that's why E is the correct answer.